So, good morning, everyone. We are back again in the session two of our international webinar on engineering and sciences. We have with us today in the second session our guest speaker, Dr. M. Shamim Kaiser. He's the professor and director in Institute of Information Technology, Jahangirnagar University, Bangladesh. And he'll be delivering a talk on next generation healthcare challenges and opportunities. So I invite Dr. Imranullah Khan to give a brief introduction about the speaker today. So I welcome Dr. Imranullah. So
Thank
the
you,
stage is
sir.
yours.
And good morning, Shamim, sir. It is an honor for us that you have spare time from your busy schedule for this valuable lecture. Shamim, sir, is working as professor at the Institute of Information Technology, Jahangirnagar University, Dhaka. He received his Bachelor Master in Applied Physics, Electronics and Communication from the University of Dhaka and PhD degree in telecommunication engineering from the Asian Institute of Technology, Thailand. He worked as postdoc fellow in the Big Data and Cybersecurity Lab of Angela Ruskin University, UK, from 2017 to 18. He also worked as a special research student at the Wireless Signal Processing and Networking Lab of the Tokyo University, Japan. His current research interests include data analytics, machine learning, wireless network and signal processing, cognition radio network, big IoT data, healthcare, neuroinformatics, and cybersecurity. He has authored more than 150 papers in different peer-reviewed journals and conferences. He is an academic editor of PLOS One Journal, a state editor of the IEEE Access and Congenital Computation Journal, guest editor of Brain Informatics Journal, IGI Global, Electronics MDPI, Frontiers in Neuroinformatics and Congenital Computation Journal. Dr. Kaiser is a life member of Bangladesh Electronic Society, Bangladesh, and Physical Society and Noam. He is also a senior member of IEEE USA and ICE Japan, and an active volunteer of IEEE Bangladesh section. He is founding chapter chair of IEEE Bangladesh section, Computer Society chapter. So I welcome sir, and I'm again thanks sir for sparing time for his busy schedule. Sir, your stage is yours now.
Thank you, Professor Khan, for your nice introduction and also inviting me for sharing my experience with the audience who already connected to this session. And also, I think you are going to share this one through YouTube. Maybe many people will watch this lecture later. So today, my talk is about next generation healthcare system, challenges and opportunities.
So kindly share your
So
screen again, sir.
can you see the screen?
Yes, sir. Yes, sir.
So the screen is visible now, sir.
Yeah.
Okay. So these are the agenda of today's presentation. I am skipping this slide. So this is the overview of healthcare process step by step. Whenever a health issue is identified, we go to meet a doctor. Doctor suggests some kind of diagnosis and medication. So through diagnosis and medication, we restore our healthy life. So this is the traditional way of healthcare process. So what about the evolution of healthcare system? In the Healthcare 1.0 tries to reduce the paperwork within the organization. In Healthcare 2, so I mean the data can be shared with the peers. In the Healthcare 3, the countrywide healthcare involves data analytics, and we are living in the era of Healthcare 4. Here we can share our data globally, and real-time monitoring of patient is possible and we are analyzing our data. We are converting our data into actionable insight using artificial intelligence. So these are the demand of Halthcare 4. So if we looked at the overview, the Halthcare 4 is basically patient-centric healthcare system, which will tell us about the health and its, the risk involved while we will operate with the patient, and what are the best option. That is the option can be chosen by the patient or its attendant. So that can also be done over here, and personalized healthcare is also possible, and patient can control everything. That is, patient can monitor, it can have access with the record and detailed treatment plan, health condition, and also risk factor. That is, if we like to ensure this patient-centric healthcare, in that case we have some challenges as well. We will discuss this one later. So healthcare for this Halthcare 4, the healthcare delivery is patient condition can be delivered, patient record, and the hospital can be bring to the patient, and through extensive data analytics, the disease can be identified easily. So these are the healthcare delivery. And what is our expectation from this Halthcare 4? The first one is low cost patient care, anytime, anywhere, best utilization of healthcare resources, quality healthcare, at the patient premises, health system integrated with the community health resources. We know that the community health suffers from the facility. All the facilities may not be available at a community clinic located at the remote location. If we use Halthcare 4, in that case, it is possible to connect that community clinic or hospital with a big hospital located in a bigger city. So for ensuring these healthcare services, we need to maintain our data in e-healthcare register. And e-healthcare register includes doctor's letter, patient condition, diagnosis report, genomic sequence data, and any kind of laboratory data, and that is everything can be patient record can be keep in this EHR. So if we looked at the data generation and the use of IoT for healthcare sector, if we looked at this graph, the demand and the generation of data using IoT is increasing exponentially, almost exponentially. And if we looked at it at this graph, the use of smart product, that is actually, am I audible?
Yes, sir, you are audible, sir. Please continue.
Okay, sorry. I'm sorry for that. Okay, so if we looked at this one, this users of smart product, that is the IoT, users of IoT in the healthcare sector, that is also increasing. I'm sharing this slide from one of my research paper. In this research paper, we have proposed Internet of Healthcare Things, its ecosystem, and possible framework. These are the application of healthcare system. Let's say the hospital can provide services, and also we can collect data from patient. If the patient is staying at the home, that is the patient monitoring at anytime, anywhere. That is also possible. And we collect this data and send this data to mist layer. Mist layer is basically rule-based layer. It will detect if there is any kind of anomaly in the node which will collect the data that can be detected at the mist layer. Most of the cases we can include if then rule over here. And then the second layer is the fog layer. Fog layer includes extensive, the machine learning frameworks. So we can do our any kind of analytics in the fog layer. But fog layer belongs to a particular hospital, and the patient record can be kept in this fog layer. And if we need additional processing, in that case, we can send our data to the cloud layer. We know that the cloud layer contain extensive machine learning platform, extensive resources can be allocated in the cloud layer. So whenever we send our data to the mist layer, then fog layer, then cloud layer, there is a propagation delay. So this propagation delay, cannot allow us to take decision, in real time. So that's why if we need any kind of real-time decision regarding a health issue, in that case, we use fog, the fog computing. If we do not need any kind of real-time, the decision, in that case, we can, process the data in the cloud layer. But whenever we will send data to the cloud and fog, in that case, the security and privacy, these are the concern. So this is another framework. This is the mist layer. This is the fog layer. This is the cloud layer. This is the patient monitoring. Let's say we don't need, the instant decision. In that case, we can, process the data directly in the cloud. We can process the data. If we need real-time decision, in that case, we can process the data in the fog layer, because fog layer is very close to your premises, and it can reduce the propagation delay considerably. So, let's say we have a smartwatch. Smartwatch is a mist device. Let's say we have a computing devices in a hospital. These computing devices can be your, the fog computing devices, and the cloud computing devices can be placed as anywhere, and that we can take the service from this. And finally, the decision or analytics can be sent to the patient through the application, different types of application. So this is an example of IoHT. Let's say we can detect our health issue using biosignal sensors, wearable IoT devices, and this information can actually, give us health data like brain signal data, cardiac rhythm data, health rate, heart rate, the blood pressure, oxygen saturation level, sleep duration, sugar, temperature, and accelerometer data. That is, we can collect a lot of data using our smart devices like smartphone, as well as our, any kind of portable device, portable healthcare device, and a smartwatch. And this data can be converted into different kind of knowledge or insight, which will, help us to develop digital health application. Let's say for activity recognition, fall detection, arrhythmia detection, seizure detection. Managing our lifestyle disease like diabetic, and also for any kind of well-being. So what are the challenges of Internet of Healthcare things? The challenges are devices and infrastructure, and most of the case there is no regularization or standardization for the device and infrastructure. Different companies are producing their own device, their own standard. So integration can be a challenge for that. Data security, privacy, we have already mentioned. We have to send our data because data should be available anytime, anywhere. So the security, privacy, this is a challenge. And we have already mentioned, there is a possibility that, or there is a, requirement that our data has to be processed in a cloud premises. So for this, we need ultra high speed access network to reduce the propagation delay time considerably, and the data should be available 24/7 because we need to, process our data anytime. So, and already mentioned about the regularization and standardization issue, and also data overhead will be increased because the control information will be exchanged. So it will, include data overhead issue. And additionally, we have to do extensive healthcare big data analytics in the cloud premises. So the devices, we have to use the smart devices to collect the data. We need high-speed access network, and these smart devices should be secure. The data generated by these devices should not include any kind of faulty data, and there should be some kind of AI and machine learning model which will detect our the diseases, as well as it will suggest us what to do. And the final thing is we have to ensure data security and node security. So for access network, we can use 5G access network, 6G access network. This network will provide us high reliability, low latency. The latency can be less than 10 milliseconds. It can offer ultra high bandwidth and support high mobility. So that's why we should, include 5G, the access network or 6G access network, because we are expecting, a doctor located in USA. Let's say there is an Indian doctor who is very good in heart surgery, who is located in USA. He can do, robotic surgery of any community clinic. So this should be allowed. So that's why we need a reliable, access network. So this is actually, this figure has been taken from the Qualcomm. Look at this one. Whenever we will include 5G, in that case, edge cloud integration is very much possible. For the traditional mobile network, it will not be possible. But for 5G, edge cloud, the delay offered by this edge cloud processing, that can be reduced considerably. So the 5G will transform our healthcare sector. So that is the bottom line. And 5G can also offer, the optimization of radio resources. If we use our resources in optimal way, it can reduce the power consumption of, the healthcare node considerably, because for IoT node, the processing as well as the power, these are the energy, these are the main challenges. So the 5G can reduce that one considerably. And it will also allow us software-defined network. Software-defined network can control all the nodes using virtualization technique. So it will allow us to separate our control plane as well as the data plane. So control plane will do the controlling of all devices and the data plane. So we can actually ensure the security of the control plane and data plane separately. And it can also provide provision for intelligent data analytics. It can ensure quality of experience of the user. Big data analytics and context awareness can also be possible. And security and privacy is also requirement of 5G and 6G. So this figure has been taken from one of our research paper. So in that paper, we have given, how we can convert our different data into different application using different deep learning algorithm and the tool. So that was discussed in this paper. So the data can be, the biosignal data, it can be imaging data, it can be genomic sequence data. So based on this data, we can develop different application. Let's say, the image reconstruction, disease detection, diagnosis, anomaly detection, drug design, and human activity recognition. So everything can be done. So this is also taken from this paper. I mean, the link is given over here. The DOI is given over here. You can check. So this is the open access data set. Let's say sequence data, imaging data, biosignal data, and I mean, using this data, which kind of application you can develop, and what kind of machine learning algorithm different authors or researcher suggested, that is actually listed over here. And this slide tell us about most popular, I mean, platform or tool which can be used for, I mean, for our deep learning architecture. If we looked at this one, I mean, the involvement with the star and for in the GitHub, I mean, for TensorFlow is highest. That is, people are contributing for TensorFlow, and it can be used in different platform. It can be used in mobile platform as well as I mean, Windows and Linux operating system. And we can write our code in language support is C++ and I mean the Python and CNN, RNN, and approximately all the deep learning architecture can be supported using this one. So there are other tools over here. We can use Cafe, we can use I mean Keras, Microsoft MCT, MXNet, Neon, PyTorch. This can be also used. So this is also a comparison of different tools. Initially, our processing, we did all the processing using CPU. Now we are demanding the GPU. In future, the processing can be done in the FTPA and ASIC. And if you looked at this bubble graph, the TensorFlow, the contribution of the people are doing the research for TensorFlow. And this is the interoperability of different types of tools. I mean, the Cafe can be converted into Keras to other tool. That is also possible. So TensorFlow to Keras, this interoperability is also possible. We have already mentioned for Internet of Healthcare things, we have to ensure the security of our node. This figure has been taken from one of our research paper. In this paper, we have shown we showed that, I mean, for a particular application, if we collect data from using a sensor node, in that case, the security of the node should be ensured and it can be calculated. So if we looked at this figure, I mean, this is the framework. In this framework, we have what we have done. Let's say this is a medical devices. These are the relays. And I mean, the medical devices send the information to, let's say, doctor. The node security of these devices as well as the relay node, I mean, should be calculated, the trust value. So through the reputation, we can calculate the direct trust value, indirect trust value, and the history of the trust value, the existing trust value can be stored in the data history. And using these things, we can calculate data trust estimation. That is, the data generated by this device is correct. And we would also like to check its malicious behavior. So for this, we used NFIS, Artificial Neurophagy Inference System, for identifying the behavioral trust. And if we combine data trust and behavioral trust, we can calculate the node trust. So for ensuring the data security along with the node security, in that case, we should use any kind of distributed security measure. We have seen people are working with blockchain for, I mean, the healthcare application. So it actually includes 3 layers. One is physical layer networks, blockchain edge layer, and then blockchain network layer. So this will actually include all the hash value. This is the, I mean, the connection, or I mean the mining between the nodes. So this is ultimately this is the final figure of this one: the data plane, control plane, consensus plane, as well as the contract plane. So this is the actually mining result. So our this has also been taken from another research paper of us. So we propose, the IOHT, it's a layer architecture. So there it should be sensing layer, access layer, fog edge layer, cloud layer, as well as application layer. We can ensure end-to-end security using any kind of distributed security measure. For controlling the device, we can use software-defined network as well as the network function virtualization. So what is the problem with the blockchain? When the miner or number of, let's say if the chain increases, in that case, the mining time will increase. So if the mining time increase, in that case, it cannot be used for real-time application. So the alternative suggestion is holochain. In the holochain, the transaction request is broadcasted or multicasted to some selected peer agent. That is, we are not sending our request to all the agent. We are selecting some agent and sending our information to selected agent. If we send our information to selected agent for the validation, in that case, we can reduce our mining time considerably. So people now working with the holochain, and they are trying to establish holochain in the place of blockchain. So this is taken from this paper, and we have found that for blockchain, this is for holochain, this is for blockchain. For holochain, if the transaction is 100, in this case the delay is the less than that of holochain. This is considerably less than holochain. So it means for real-time application, we should look at some kind of alternative like holochain. So this is the blockchain and holochain integration. We can use blockchain and holochain together. And let's say these are the holochain, and this is the integration. This is the blockchain. So we can use blockchain and holochain. Let's say in overlay fashion, and the other option can also be explored. And we know that the security of data and the privacy of data is a concern. So federated machine learning will be the ultimate solution for ensuring privacy of the data. Let's say this is a hospital located in Mumbai. This is a hospital located in Delhi. The hospital of Mumbai are not interested to share their data with the hospital located at Delhi. So what we can do, let's say we would like to design let's say a system which will detect a particular type of anomaly. So for every every problem we can develop, we know what kind of model is appropriate. Let's say for image analysis, CSN based models are very, very much appropriate. So let's say one model is prepared based on traditional data, and this model can be shared with hospital in Mumbai, and they can actually train their this model with their own data and send the machine learning parameter with the server. Similarly, the other hospital can do the same thing, and based on this parameter, we can, using statistical inference, we can actually design a global model. So hospitals are sharing only the model value, not the data. So in this way, we can ensure the privacy and security of the data. So this is a figure for federated machine learning. And federated machine, there are some advantages of federated machine learning. Let's say, the data of a particular hospital are not very good quality, and the data of a particular hospitals are very good quality. In that case, the global model can actually eliminate the effect of a particular hospital. And also, if there is an attack, we know that for machine learning there are lots of attack. The one attack is the poisoning attack. That is, the poisoning attack can actually deactivate a particular node. So since we are combining the different model in the central server, in that case, this positioning attack can be detected and this can be recovered. So in conclusion, I mean, our suggestion is in future, we should use, I mean, the access network like five generation, I mean, the access network as well as the sixth generation access network. We should use AI and machine learning. We should use blockchain. We should use node security measures. And if we include everything, in that case, we can, I mean, we can have a next generation healthcare system. So before, before the conclusion, I would like to share one of our project. This project is called Diverse Asia. This is European Union funded project. In this project, our aim is to provide, accessible tools and devices for students with disability, and so that, I mean, we can bring them in the mainstream, and they will get equal facility like our normal student. And in this project, there are 11 partner from different countries. India and Bangladesh are also the partner of this project. And my university is a partner of this project. From India, IIT Bhubaneswar and VIT, they are also partner of this project. So I mean, if you like to contribute, if you like to do some kind of collaboration, in that case, you can collaborate with us in this project. This is European Union funded project. The students or any faculty member can work with me and us in this project. And also, we have also some other project like health related to neuroinformatics, as well as Alzheimer detection and management of autistic students. We can also contribute over there. Thank you so much for giving me this opportunity for sharing my work with you.
Thank you so much, sir. We now open the house for the question answer session, and let's take up some questions from the participants of the event. So it will be on your screen. Yes. So just like we have internet service providers, should we ever expect healthcare service providers with the advent of IoT-based healthcare systems? So I think it's... So would you like to answer that?
Sorry, I couldn't get the question. I got this is a statement. So
Yeah. So
anyway,
I think it is a question only, but it is saying
okay.
that...
So I think, in my opinion, our main challenge is the access network. For wire-based system, I mean, for the tradition, let's say we have an optical fiber link. In that case, we can send, data in real time. But the challenge is the access network. If we have wireless access network, in that case, there is a delay. We know that in the traditional, let's say in 4G, our maximum, we will get maximum 15 Mbps or 20 Mbps speed. For, let's say for any kind of surgery, the requirement could be 1 Gbps. So it could not be ensured using the traditional system. And also the reliability is also a challenge. Security is also a challenge. For 5G, the cell size is smaller. In that case, ensuring privacy security is much more easier.
Okay, so let's take the next question, sir, on your screen. So it says, what are the challenges of IoT in healthcare? What system can be incorporated to ensure data privacy? I think you already discussed in your
Yes,
lecture.
I already mentioned,
Yeah.
data security is a challenge.
Yes.
For ensuring data security, federated machine learning can be used, number one, because I'm not sharing my data. I'm sharing some parameter with the other partner.
Yes.
And this parameter is, there is a reflection of the data, but
Mm.
since they are not getting the data, privacy can be ensured. So now people are working with the federated machine learning.
Okay, sir. There is one more question from the participants. He says, "My question is that what industries can benefit from IoT?"
Actually, IoT can be included almost in in every application, because IoT platform will give you the facility so that you can collect your data using different sensor nodes. So for automating our system, we need data. Without data, we cannot automate our system. So whenever you will collect the data, whenever you have data, in that case, you need to collect the data using IoT, and this data can be used in almost all the applications or all the environment also.
Okay. So that is all for today, sir. Thank you for sparing your time. Your valuable lecture will be definitely benefiting our research scholars and the scholars working in the IoT sector. Imran, sir.
Thank you, sir. Thanks a lot for this nice and informative lecture. I
And I
am
will also share my
anytime.
slide with you. You can also share slide with. Thank you so
Okay,
much.
Okay.
sure.
Thank you so much, sir.
Thank
Thank you
you,
so much.
Imran sir, and
Thank
thank you,
you.
Priya sir. Thank you so much.
Okay, thank you, sir.
Most welcome, sir. Most welcome. So the participants are requested to wait for the third session. The link will be provided, and you can join in the YouTube stream there as well. Thank you.